The universe is made up of several specific elements. Space is the potential, but how this potential is defined is more important and more specific algorithm universe theory. So, what are the quantum parts of the universe? The first quantum part of the universe that we will be examining is CT1, or space. CT1 changes differently than the other aspects of quantum elements of the universe, and this is the reason that gravity and dark energy, which is also anti-gravity under algorithm universe theory, is seen to function so different. It appears that the best model for space is a series of quantum points that evolve according to the f pi x algorithm. F pi x is what's better known as the denominator for pi. There is a counter which is believed to function in what we call CT0 space, which counts from 1 to infinity. Best explanation for this in terms of origin, the universe looks at itself and says not nothing, which is -1, and then not nothing, which is 1. For our purposes and for purposes of examining CT1, what is important is that there's a counter in the background that counts from 1 to infinity. Were this counter to ever stop, then the universe would cease to change. It would, in effect, freeze in place as long as the memory of the universe remained. Otherwise, it ceased to exist entirely. Because of this counter, f pi x starts at -3 and stays in that form for 3 beats. At the end of those 3 beats, it changes to 5 and exists as 5 for 5 beats, and then it changes to -7 and continues there for 7 beats. It is theorized that for each change in x, a new -3 is created, so that by the time that the first 5 begins to exist, there have been 4 -3. The reason for this is that the universe is considered to have a perfect memory. The same is true for the 5. First 5 exists for 5 beats, and during that period of time, 5 -3s have changed to 5. Because of this feature of the universe, each quantum point in the universe is slightly offset from the other, but particularly in very large sets of the type that exists where x is a factor of 10 to the 40th or 10 to the 60th, considered to be the minimum range where our universe, or our portion of the universe, the galactic portion of the universe, exists. There are very large numbers of similarly situated quantum elements that have long lifetimes in terms of changes in x, basically 2 times whatever the average value of those points would be. If you want to see more about how the complex interaction of these f pi x solutions work together and how the universe would have at least 10 to the 100 separate f pi x solutions, books 1 through 3 and Books 7 and 8 go into this in some detail. It's worth noting these changes occur in a time and dimension-free environment, but that the solutions may be separated according to their solution order. At what we view as the edge of the universe, it is theorized that new -3 solutions are being constantly generated, and as what we view at the very center of the universe are the slowest changing values of f pi x. Only in the middle part of the universe where we exist are the changes at a speed that is conducive to thought and life as we experience it. The next element in the quantum parts of the universe has to do with the new method of creating transitions, which is called compression. Compression takes the alternating positive and negative state and uses those in order to create dimension and the resulting forces that we experience. Compression requires information arms which form on the scale of 2 to the n, where each CT state has a different value for n, from 1 to 5 in the observed universe, 1 being space and 5 being black holes. Because there are 2 to the n information arms for each state for the light, the number of information arms is 2 to the second, which is 4. There's another part of the equation, however, which has to do with how much information is on each information information arm. This will be discussed in reference to the next slide. As information arms are filled with either positive or negative values, theoretically alternating in order to create neutral values, the next compression state is formed. For purposes of the transition from CT1 space to CT2 photonic light, it is theorized that there is one photonic light state for each 256 aligned CT1 or space state. Dimension is created by taking the higher CT state and folding it, although the initial folding is probably just the relationship of two photonic CT2 states with a minimum amount of intervening CT1 states. Therefore, the folding of the lower information states together upon the creation of higher information states increases the number of dimensions and also traps the lower compression states within the matrix of the higher CT state. So that within CT4, the state that we think of as mass, there are massive amounts of wave energy, CT3, which in turn has trapped massive amounts of CT2 photonic energy, which in turn have trapped massive amounts of CT1 space. What we see as velocity is the release of these CT1 states that are trapped within the matrix of the CT4 state. This is an important feature of algorithm universe theory, which allows us to understand why the universe is expanding. That is, these trapped CT1 states are being released as the universe goes through a net decompression phase. It allows us to calculate when the universe will stop expanding and begin to contract, and it provides the explanation for gravity, which is the tendency towards compression, anti-gravity or dark energy, which is the tendency towards decompression, and it helps us to understand where the other forces come from. While it will be covered later and in more detail, forces are basically created by the filling of information arms and the breakdown of information arms. The idea of quark, fermions, and other features that are part of pre-AUT physics are eliminated in their entirety and are merely effects that are seen from an examination of the results of the breakdown or buildup of these information arms. Further, as can be seen and will be discussed in more detail, velocity is not a feature in the supersymmetry universe because the supersymmetry universe exists as quantum points. That is, there is no movement at any value of x for the universe, but instead the universe is fixed at that point. Hence, any examination of CT states in terms of time and velocity will necessarily be flawed, and in fact, time does not even exist at the CT1, CT2, and CT3 levels, and is only a feature of the CT3, CT4 transition. For this reason, the early experiments looking for evidence of the theoretical ether were flawed because they assumed that CT1, CT2, and CT3 states would be subject to time-based features. Looking at this another way, this explains wave-particle duality. Wave-particle duality is the idea that there's some relationship between the particulate and wave features which allows them to transition instantly between one another. AUT explains this by showing that the transition between photonic light and wave energy occur in a time-free environment and hence appear to occur unrestricted by time, since time does not exist for them, nor do three dimensions exist for them. Instead, these one-dimensional photons transition to two-dimensional waves and back again, solely based on how they are solved in conjunction with evolving f pi x solutions and compression in a 1 to 2 dimensional time-free environment. As will be discussed later, time is not a dimension but merely an effect that results from preserved information in the electron bundles around proton in the CT3, CT4 transition. If the universe is an algorithm, it should be possible to explain the process in terms of a domain, an operator, codomain. The data can be seen as f pi x solutions starting at -3 and going up to some very large number on the scale of 10 to the 100th or even higher. The solution order is preserved as part of the generation of the data. The domain, therefore, is continually increasing in terms of quantity. There are two operations that affect this data. The pre-operator generates -3 numbers and generates a value of x from 1 to infinity, basically generating one -3 for every x generated. It also preserves the solution order of these generated results. The first operator shown on the slide changes the -3. Operation 1 can be summarized as generating quantum points and assigning them positive and negative values, generating the features from which gravity and anti-gravity come. From a programming standpoint, the operator would look something like this. Change x by adding 1 to x. For each change in x, generate a -3 solution and preserve that solution along with any changes that occur to that solution. Determine the absolute value of the number, which in all initial cases will be 3, and after that absolute value number of changes in x, multiply the value by -1 and add 2 if positive, or subtract 2 if negative, and then repeat step 3 for the new value, substituting the new value for -3 as long as x continues to change. This rough description of operator 1 generates all the points in the universe and gives a net value of gravity versus anti-gravity for any value of x, keeping in mind that x probably has a value scaled at least to 10 to the 100 as this document is being prepared. The codomain then is the next f pi x value solution order preserved set of data. This becomes the new domain. The second operator on the new domain is the compression-decompression cycle, which yields a net regional value. This in turn generates the next codomain, which is the compressed CT1, CT2, and CT3 states, and in the example shown generates a combination of these folded in order to make a CT4 state. All of these CT4 states together would define the universe quantum state for any value of x. Operator 2 is discussed in detail in slides 5 through 7, but it can be roughly set out as follows. 1. Determine a proximity ratio for photons into arms, probably 0. If the proximity is reached, match set of CT1 data based on positive adjacent to negative as the limit of separation between matched sets approaches the proximity ratio. The proximity ratio in this case is probably 0, so this is a limit function as the limit between the two approaches 0, that is, intervening alternatively charged states approaches 0, the necessary proximity ratio is reached. The next step is to set the number of information arms at 2 to the n, where at this stage n equals 2, so that there are basically 4 information arms. The next step to determine a second proximity ratio for the information arms, possibly also 0 in this case, but certainly higher after CT1 to CT2 transitions based on observed proximity ratios. If the second proximity ratio is met between matched set, then the information arms, 4 information arms, begin to be filled, and the next step would be to repeat those initial 5 steps as n increases for higher CT states. Operator 2 appears to be more complicated than operator 1, but the only feature that is missing is the equation for how the proximity ratios are obtained and maintained. It is worth a small wager to say that the equation is based on the next lower information state. For example, in the ratios for sine of pi negative 1 to pi 1, you generate a ratio of 256:27. This 256 is the same value for compression for CT1, CT2, and is where the 4 information arms are generated. This suggests that the PR ratio, the proximity ratio for alignment of positive and negative CT2 states to begin the CT3 generation might be 256 or a function of 256. But for the moment, it's an example, we use 256. This means that you can have 256 intervening CT2 states between each CT3 fold or each CT3 information arm. Perhaps it also means you can have matched positive and negative values because of the intervening lower state. For the CT1, CT2 separation or proximity ratio, one easy choice would be to say the plus-minus separation was 27 and the information arm separation was 256, but there's no reason to have this type of broad separation at the CT2, CT3 level because the CT1 separation is not particularly relevant, although that is not to say that determining what the proximity ratios are is not critical to a full understanding of the universe. Allowing CT2 states to begin to align with 256 intervening CT1 states is important, however, since the generation of electromagnetic fields is a function of incomplete information arm filling along the very large compression scales for waves, which are 1.7 times 10 to the 6. Which are covered in more detail in a later slide. Since the universe exists as quantum states, that is, the universe is a series of slides which are thermodynamically independent or independent of thermodynamics, at the early stages of the universe, the flux between these features would be such that it would be a mess in terms of rapidity of change, and there's not time to fully evaluate what that flux would look like in the connection with this slide. Since the number of changes in x within a second are enormous, the lowest number being on the scale of 10 to the 39th changes in x for every second, until you get very high values of x, things change too fast for the stability of a system which we experience, which is one of the reasons we know that we exist at a time of high values of x, although at the extremes of the universe there are both very high and very low values of x relative to the values which we experience at this midpoint in the universe. There are positive and negative values of every CT state. One of the results of the way that the universe generates information and changes the information is that at any point in time, any information is liable to be changing in one direction or another, towards compression or away from compression, towards generating gravity or away from generating gravity. The chart shown in this slide shows how the positive and negative values of CT1 are embedded in more compressed states, any of which may at any point in time pull either towards or away from compression. Each quantum piece of the information is constantly pulling towards or away from compression, and the direction changes as gravity or dark energy. The compressed pieces pull together or pull apart from one another based on the net charge of the combined pieces. Having discussed the creation of CT1, it's now time to look at how CT1 states fold and compress in order to get to higher states. The basic equation that leads to the compression is 2 times f of x raised to 2 to the x. F of x is the Fibonacci number for x. For x equals 2, this is merely 1 plus 1. For x equals 3, it's 1 plus 2, and for x equals 4, it's 2 plus 3, and so on. This generates a scale solution for each type of state. Photonic lights 4 to the 4, black holes are 16 to the 32nd by way of example. The value of x corresponds to the number of places mathematically. X equals 1 is the ones place, x equals 2 is the tens place, x equals 3 is the hundredths place, x equals 5 is the 10,000th place by way of example. And x equals 4 would be 1,111. An x equals 3 number would be 111. This solution order, which is a part of the Fibonacci compression, is very important because it corresponds to the number of dimensions and also is extremely important in determining how things like time dilation and velocity work. All of the detailed features that result from this, force, gravitational features, time dilation, and the like, are going to be covered in separate videos because of the amount of detail necessary in order to present those. However, this underlying compression table contains all of the information necessary in order to evaluate what state is being examined, although transitional states between these are fairly important. For example, in the transition between x equals 3 and x equals 4 is where the electron and proton exist, and once it reaches a full x4 state, you have a neutron, and likewise molecules up to the level of a neutron star or transition states between x4 and x5. Dimension corresponds to compression state. For example, photons exist as a one-dimensional state. Space has no dimension, although it does have solution order that allows CT1 states to compress through alignment. There's a lot going on in the next slide. It shows an example of charge alignment, but it also shows how space is converted into photons, which is the first step in space turning into matter and even black hole material. It should be understood that this is a two-way process, so that the conversion can go both ways, as compression and as decompression. During this process, space is actually trapped within a matrix, and when the space is released, it carries the photons with it, and this is what we observe as travel at the speed of light. There are two examples shown in the drawing. The one on the left is the balanced or equal alignment, and the one on the right is the building or unbalanced alignment, which is the one which AUT currently accepts as the accurate model based on observations at the electron, proton, neutron scale. At the very beginning of the process in both drawings, the generation of space is shown. Space begins with alternating positive and negative results in an equation, and these are then aligned according to the f pi x equation into durable or partially durable f pi x solutions. In order to understand what the information arms represent, it is necessary to break down into component parts the features of the information arms. An information arm can be defined as aligned states of the next lower information state, NLIS, a specific low number, SLN, of intervening second lower information states, 2LIS, and the subsequent alignment in such a way that the two LIS states making up the SLN are effectively trapped within the folds of the information arms. There are ultimately 256 aligned CT1 states making up a single CT2 state, although there are more trapped CT1 states within the folds. It's worth repeating that while the compression is 1 to 256 between space and photons, it quickly rises to 1.7 times 10 to the 6th for photons to light and 1 times 10 to the 16th for matter. The ratios are space to photons, then photons to waves, and finally waves to matter, and not space to each higher state. This exponential increase in the amount of information and the number of states that can be trapped within folded information arms creates a dynamic matrix that gives rise to the linearity that we observe in the universe. According to the building unbalanced model of CT2 information arms, you begin with 2 CT1 states on the first information arm, 4 on the second, 64 on the third, and on the final one you have 256 aligned CT1 states, creating a stable photon. Because of the large number of intervening CT1 states possible, the photon remains stable over a long period of time until the number of unaligned intervening states exceeds the maximum, at which point in time presumably the photon would break down into space. It's worth noting the Big Bang was nothing more than the inflection point when the number of CT2 states breaking down into CT1 states exceeded the number of CT1 states compressing to form CT2 states for the universe as a whole. A separate slideshow goes into more detail on the nature and effects of compression. It can be found under Algorithm Universe Theory on YouTube. Fundamentally, F-series compression is the best model that has been determined for showing how space builds in order to form mass and even more compressed states of information. As was previously discussed, there are 2 to the n information or compression arms, also sometimes referred to as carrier arms, for each CT state. The loading and unloading of the compression arms gives the effect that we call force, and the arms themselves are the different structures of the universe. The drawing on the right shows how these states build in terms of the amount of information in each one, and the drawing on the left shows the black hole information arm, that is 3.4 times 10 to the 38 neutrons. This can also be referred to as 16 to the 32nd units of CT4 neutrons. To give an idea of the amount of information involved, this is 10 to the 63rd spatial units, that is CT1, and around 5.7 times 10 to the 60th photons. Even at CT4, the neutron starting point, there are 10 to the 16th individual wave quantum states, translating to around 1.68 times 10 to the 22nd photons. These staggering amounts of information, even at the neutron level, should not come as any surprise. In Book 2, the 3rd edition, which is currently available, some rough calculations are done to show that in the universe at the present time there are a minimum of 10 to the 100 quantum information states, or CT1 units, and the length of an information lifespan at our point in the universe is on the magnitude of 10 to the 40th or 10 to the 50th at a minimum. While this might seem to lead to a slow-moving universe, the number of changes in x per second is on the scale of 10 to the 39th to 10 to the 44th, depending on how the calculation is performed. While this might seem to lead to a slow-moving universe, the number of changes in x per second is on the scale of 10 to the 39th to 10 to the 44th, depending on how that calculation is done. So even at our place in the universe, it is a dynamic universe where seconds actually matter. The loading of information arms ties forces to place to dimension, and ties all of these together to compression states. Forces are the resulting observed mathematical results tied to the filling or emptying of transitional information arms. The strong force is compression or decompression at the CT4, CT5 transitional state, which is where neutrons and protons are joined in order to form larger molecular structures. The weak force is the compression or decompression at the CT3, CT4 stage. The electromagnetic force appears most predominantly at the CT2 to CT3 information arm, although there is some indication that the CT1 to CT2 transition might involve some aspects of magnetism in the form of transitional photons. Because of the differences in wave-particle duality under AUT and under the standard model, this is not necessarily the case. Even gravity is part of the information arm building and unbuilding process. Gravity appears to be different because it results from the interaction of a non-dimensional element space with CT2 or photon carrier arms. Gravity is caused by folding and unfolding of CT1 states within CT2 states and the subsequent exponentially greater folding that occurs in higher CT states. Compressing or trapping CT1 states within CT2 state folds is seen as gravity, and when the CT2 states unfold to release the CT1 states, you have anti-gravity. The reason we have an expanded universe is because the amount of CT1 states being released from compression are greater than the number of CT1 states being trapped within compression. The electron-proton-neutron conundrum is, why doesn't the electron-proton pair collapse into a neutron? Why is the electron-proton pair the primary stable pairing of transitional states in the CT3-CT4 transition? And how do the CT4 information arms fill, and what does that tell us about the filling of other information arms? AUT is going to take the position that a proton-electron pair are nothing more than a complete neutron along with an intervening cloud of information, just a neutron that is in the process of breaking up or staying together because of destabilizing changes in the constituent parts. The drawing on the left shows what a CT3 state would look like when filled and what a CT4 state would look like when it's filled. But it's important to understand that while these show the number of information arms and how those information arms might be filled, this is actually just a series of mathematical solutions. The drawing on the right shows how the electron and proton pair might be represented as they transition to a neutron. Since a neutron can be thought of as 16 information arms that are filled, in this case we're going to look at the electron-proton pair as the electron having 7 arms filled and the neutron having 9 arms filled as the most likely way that these two exist as a proton-electron pair. That being said, the net effect comes out this way, although it is also likely that other pairings that add up to 16 might be possible because of the high state of flux in any solution order allows us to think of the universe as a string. There is no dimension to this line of solutions, but there is a relative solution order. The f pi x values, or CT1, of space have no dimension, but they do maintain a solution order. The CT2 states trap space within them as they compress, and during decompression the release of CT1 is seen as velocity. Likewise, any exchange of CT1 states in a higher compression state would be seen as vibration. The line gets incrementally larger with each change in x. It also The amount of information that can be between two higher CT states grows exponentially the higher the CT state is. This is actually witnessed because if you look at two black holes, which are CT5 states, there is a massive amount of lower state information between them. If you look at a neutron, which can be broken into a proton and an electron cloud, just between the proton information arm and the electron partial information arm is a massive amount of information in intervening states, which must be further compressed in order to join the electron and the proton into the neutron. Dimension builds and breaks down based on the folding of information states. The two-dimensional representation shown here shows how a line beginning at A and ending at D has intermediate points, and three of those have been labeled as C, B, and F. Originally, if this line was straight, it would represent space, and a dimension was added when it was folded. This drawing is two dimensions, which takes into account fold has a different effect when non-dimensional solution order is folded to make space, to make photons, which exhibit a single dimension. So even though this is the third folding, it represents the folding of space as CT1 to photon CT2 with a single dimension, and then a third folding of CT2 states to form waves or CT3. The first fold can be seen as a position from which the other folds can be observed and is represented by gravity as opposed to dimension. Point F represents a fold leading to a greater dimensional concentration, and points B and C can be seen as trapped CT states that might pull the. Some of those elements predate even algorithm universe theory, but are worthy of mention. They are the ability to hold a equation, a very special kind of equation, to keep the solutions durable and to act on them one quantum element at a time. In later editions of this, extensive amounts of time will be spent discussing the part of the universe that predate the part from which thermodynamics and dimension arise, but for purposes of this lecture, we will concentrate on the portions of the universe that begin at space. Before AUT, space has been something of a mystery, but there were certain observations early on in space that proved to be largely more important than subsequent science would indicate. The idea that space is filled with ether, for example, was discounted based on experiments which are explained in books 7 and 8 of algorithm universe theory to be flawed given the true nature of the universe. Instead, space has been defined also with partial accuracy as being the potential for various features. One element of the thought process in this regard is that this would mean that space would occasionally spontaneously generate light, and this in fact is a possibility, but because of the slow speed of transitions at our point in the universe, this occurs much less frequently than might otherwise be imagined. The light that we witness is primarily light that is generated from the release of CT2 states from higher information states.